Hey guys, what's going on? It's Jacob Getz. I'm in your 1106 college liberal arts math class. Sorry it's taking me a little bit to get this video out. I made one yesterday, but GroupMe is really weird where like you can't post a video longer than a minute, and I didn't want it to be all choppy. I wanted it to be together so you could pause, rewind, and go back and not have to flip between videos. So that's what this is gonna be. I'm just gonna kind of go over the first few pages, the ones we've gone over in class in the notes packet. Just kind of, go over in little detail, how to do the problems, just show some practice. Because, when you get the math class together, when you got people, who are willing to help each other, that makes it a heck of a lot easier. So I'm first going to start with the universal set and we'll work our way down. So when working with these universal sets, what you have to know is that it's important that you have to have one thing. You have to have your universal set. So our universal set for these practice problems is going to be 1, 2, 3, 4, 5, and 6. Okay, so we have our universal set. And then we have to look at the sets that, the individual sets that are going to be working with our universal set. So we know our set A is equal to 1, 2. Our set B, according to our little answer key here, is going to be 2, 3, and 4. 2, 3, and 4. And then we come back and we see that set Z is 0. It's just an empty set, or you can write it like that. But if you're going to be working within a problem, it's always best to write it that way. And set D is 1, 6, 1, 2, 1, 6, 4. 1, 6, 1, 2, 1, 6, 4. Now we have our universal set and we have the individual sets. So the first thing we have to do before we can do any practice problem is we have to fix set D. And the reason we have to is, according to our answer key up here, set D, in order for it to be a set, it can't repeat numbers. And we see here that numbers are being repeated. So we are going to rewrite this set more properly. So it's going to be 1, 2, 4, and 6. That makes it a lot easier because you're not having to write this big set out, and you have all of your numbers here that you know you're going to be working with. So in order for set D to be proper, you can't rewrite numbers. We got it written out properly. So let's go ahead and dive into some practice problems here. By the way, I'm going to be posting this video on my YouTube because of GroupMe, the weird minute thing. And then I'll share the link in the GroupMe. So let's go ahead and do the first problem here, which is A union B. Okay, so first, when working with these math problems, I think it's always best to write out set A so we know what we're working with, which is 1, 2, and set B, which is 2, 3, and 4. Cat wanted to say hi, sorry about that. I love you. So now that we've got our sets written out, we know what we're working with. Let's go ahead and find out what we have to do in order to make them a union. We're going to come over here to our answer key, and we see that A union B is when we put them together, but we do not repeat elements. Meaning, just like what we did for set D, we're going to put these two sets together, but we're not going to repeat numbers. So let's go ahead and write it out, but not repeating numbers. So we see from here we have 1. We have 2 2s, so they're just going to be put together. We also have a 3 and a 4. So the numbers included in the set are 1, 2, 3, and 4. That's what we see here. that is going to equal the A union B. We've put the numbers that are inside of the set together without repeating numbers. And it's always nice to add a little why, just a little explanation. I know that really helps me. These are the numbers. Sorry, kind of hard to write and work the camera. In sets A, B, without repeating numbers. So that's what we're going to have right there. That's the little explanation, and that is our answer right there. It is going to be 1, 2, 3, and 4. And again, I'm sorry about my handwriting, guys. Let's move on to another question here. We have A intersection B. So the first thing we have to do is we have to write our sets so that we know what we're working with. A intersection B is 1, 2, and set B is 2, 3, and 4. Boom. Now let's go ahead and find out what intersection means. According to our little answer key here, what is in both? So we have to find out what numbers are in both sets. Well, we take a look right here, we can see that both 2 and 2 are intersected. They're both in sets A and B. So I'm going to write out A intersection B is equal to 2. Now you have to write it out in a set form. When it's a question like this, the answer has to be in a set. And then we can write our Y. Both sets A and B have the number 2. Boom. That is our explanation right there. And that is the answer. Both sets A and B have the number 2. You can see from here from our work, and that's how you find the intersection. Move on to another problem. B complement. So let's go ahead and find out what B complement is. So always write out the set, kind of give you a visualization of what you're working with. 2, 3, and 4. And then let's come over here. Let's figure out what we're looking for in B complement. What is in the universal set that is not in the given set? Okay, so when it's asking B complement, it's asking what numbers are in the universal set. So let's see what we have in our universal set. Going back to our construction right here, we can see that the universal set is 1, 2, 3, 4, 5, and 6. Okay, so we are looking for, in the complement, what is in the universal set that is not in the given set. So let's find out. So 2, both 2 are in the given set and the universal set. So that answers out. 3, same case, and 4. So now we're left with these numbers right here. These numbers are in the universal set, but they're not in set B. That's what the question was asking. So B complement is equal to 1, 5, and 6. And then always as a personal note, let's go ahead and add our Y. These numbers are in the universal set, but not set B, which was our given set. Boom. Got that one taken care of right there. We figured out what was in the universal set and set B. You troublemaker. Figured out what was in both the universal set and set B, and we were able to pull out what was left in the universal set. And then there's our explanation right there. Get a nice shot of that. Okay, let's go ahead and move on to the next practice problem, which we can see here is n parenthesis a. Let's go ahead and write out our problem really quick. N parenthesis a. Then we're going to come back to our answer sheet. These are cardinal numbers, cardinal numbers. And then what is the number of unique items in a given set? That's worded kind of weird, so let's go ahead and, before we dive any deeper, write out what set A is. We can look back up here. We can see that set A is 1, 2. All right. So we have 1, 2, and then it's asking in the cardinal number, which we're looking for right here, come to our answer key, the numbers of unique items in a given set. Essentially, it's asking, when it's like that, how many numbers are in set A. If there was a B here, how many numbers are in set B, and same on and so forth. So when it's asking how many numbers are in the set, all we have to do is go, well, there's 1, and there's 2 numbers in there. So n parenthesis, A is equal to 2. And this is not going to be in a set because we're just counting the numbers. This is not required to be in the parentheses. And then we add our y. There are 2 numbers in set A. And there we go. Let me go and get a nice shot of this first page here so you could hit pause and just kind of work through them and, see what you'd like. Alrighty, now that we've gotten that, we're going to do a few practice and then I'll move on to the next section, which we learned on Thursday. And again, guys, if the video quality is low, I'm sorry. Sorry about that. I've never really been big into video making. Let's go ahead and move on to the next question. So we just finished NA. NC, it's going to be the same thing. It's asking how many numbers are in set C. How many numbers are in set C? That's what that cardinal symbol or n in C, parenthesis C is asking. How many numbers are in set C? Well, let's go back to our guide here. We can see that set C is empty, 0. So let's go ahead and write out set C, which is equal to nothing. So there are no numbers in there. So the answer equal to 0. There are no numbers inside of set C. That's a pretty easy one. Let's go ahead and, get into question F right here. 5 EB. Now, what's that asking? If we go back to our answer key, if we get confused, we can see that, this symbol right here, it's asking, is it a member of or is it an element of? Let's go ahead and write out our problem right here, which is 5 E asking B. So let's go ahead and write out the question. Is 5 in set B? Is the number 5 included in set B? Well, let's go ahead and write out our set B. We look over here, we can see that set B is 2, 3, and 4. 5 is not in set B, so 5 EB is false because 5 is not in set B. All we have for set B is 2, 3, and 4. Let's go ahead and try the same question, but with a different set. Come over here, we'll write 5EA. And again, it's asking, is 5 a number in set A? Let's go ahead and write out set A. And from our answer key here, we can see that set A is just 1 and 2. So I don't see 5 in there. So 5EA, false. Why? Because 5 is not in set A. Boom. And we're going to do 3 more problems with this kind of stuff, and then we'll move on to the next section. Just get a shot of that so you can hit pause, go back, kind of review, look over everything. There we are. All right, shaky camera work. Moving on to our next question, 5 subset, so A subset U, I apologize. Let's go ahead and write out that problem. A subset U. A little more clean there. And then, let's go ahead and before we dive into that problem, we have to figure out what we're working with. So set A is equal to 1, 2, and set U, the universal set, equal to 1, 2, 3, 4, 5, and 6. Okay, so let's go ahead and figure out what the heck does that symbol mean? What is it asking? All the elements in set A are in set B. So we have to figure out, are all of the numbers that are in set A included in the universal set? Because that's what the question is asking. Well, yeah, 1 and 2. So this is true because set A has 1, 2, and the universal also has 1, 2. So that's how you do it. We figured out that both 1 and 2 are included in the universal set. So yes, that is true. Get a shot of that before I turn the page. Now let's do one more problem dealing with this kind of question, and then I'll move on to the next section. Let's look at our problem here. A U. So this is asking for a proper subset. So let's go ahead and write out our sets so we know what we're working with before we begin. We have 1, 2. Then we have the universal set equal to, remember from there, 1, 2, 3, 4, 5, and 6. Alrighty, so we have our sets here. We know what we're working with. Let's figure out what the question's asking. All of the elements in set A are in set B, but they are not equal. Well, so essentially it's asking is, are all of the numbers in set A in this other set right here, but they're not equal, meaning one might have more numbers than the other. Well, let's go ahead and figure that out. So it meets the first qualification. Let's go ahead and write out same numbers, different value. So yeah, we can see that both checks are met because 1 and 2, 1 and 2. Well, yeah, great. They both have the same numbers, but the universal set has more numbers than set A. So this is true because, sorry. Both sets have the same numbers, but set U, or the universal set, has more. Alrighty, so that's a review of the first day's content. I'm going to upload this to YouTube and share the link, and then I'll get started on section 2. Thanks again, guys.